Okay, welcome back. So we're continuing our Unit 1, Lesson 1 today by talking about what's called linear regression. Linear regression is one of the most common uses of lines in the quote-unquote real world. It's used to not only find a trend or a pattern, but use that trend or pattern to find missing information or to what's called extrapolate and find information of the future, make predictions. That's why it's so valuable. So let's take a look at what linear regression is. Now, we're going to take a look at a table of data here. Now, this table of data is going to go from 1957 to 2019, but it's not every single year. So I'm going to write down the year here, and then the population. And this population is the accurate population of Montana from the records that we have. So in 1957, the population of Montana was about 667,000. So I'm going to write that as 667. So that means that my population is going to be times 1,000. You're going to need to keep that in mind. The next year I'm going to look at is 1970. And the population of Montana is 697,000. Then I'm going to jump all the way ahead to 2005. When the population was 934,000. I'm going to go to 2007, when the population was 957,000. I'm going to jump to 2009, when the population was 974,000. Next we got 2011, when the population was 997,000. Now we'll do 2013, when the population was 1 million, and since I'm multiplying this by 1,000, 1 million looks like 1,000, so it's 1,014,000. I'm going to jump to 2015, and then we'll do one more after that. So 2015, the population was 1,030,000, and in 2019, the population of Montana was 1,069,000. All right, so there's a few different ways we can go through how to create this regression. The easiest way, and the way I'm just going to have you guys do it right away, is to use a regression calculator. And the regression calculator that I think is easiest to work with is actually the one that's on Desmos. So I'm going to show you Desmos.com here. When you just go to Desmos.com, you can log in or sign up. You don't have to, though. I'm just going to open up the graphing calculator here. If you log in or sign up, you can save your equations, which can be helpful for stuff that we're going to be covering later in the year. That's not what I want to do. I just want to move you. There we go. All right. So to enter a table in Desmos, you're going to hit the plus, and you want to enter a new table. You want to make sure that you're paying attention at least. They don't have to be X1 and Y1, but you're at least paying attention. Now when you're entering information into a table, I could enter the years as 1,957, but that's going to make my X scale so gigantic. Instead, I'm going to consider 1957 to be year 0. And then all of the other years are going to be years since 1957. So the population in 1957 was 667,000. The next year I had was 1970. 1970 is 13 years from 1957, and that had a population of 697. The next year I had was 2005, and that is 48 years from 1957. And in 2005, the population was 934. Next I had 2007, which is 50 years, and the population then was 957. Next I had 2009, which is 52 years. Yep, that's right. And I had a population of 974. Next I have 2011. And that had a population of 997. Next I have 2013. And that had a population of 1,014,000. Oh, I guess I just have to enter as 1014. Don't put it in the comma. All right, good to know. Next is 2015, and that had a population of 1,030,000. And last is 2019, which had a population of 1,069,000. All right, now to do anything with this, before I enter my equation here, I want to properly scale my graph, because as you can see right now, it's going from -10 to 10 on x and from -7 to 7 on y, which doesn't make any sense because our numbers are significantly, oh, good lord. F's in chat if you guys saw me make that mistake. It should be 54, this should be 56, this should be 58, and this should be 62. All right, so my x-axis needs to go from 0 to 62. So I'm going to go to my little wrench icon over here. And my x-axis, I'm going to go a little bit before 0, so let's say -1. And I'm going to go to, say, 65, so that I can cover everything. My y-axis needs to go from 0, or not from 0, it needs to go from 667 to 1069. But when you're doing something like this, you never, ever, ever want to have a break in your y-axis. So you might be tempted to just start this at, say, 660, and then go up to, I don't know, like, say, 1070. But that's going to cause kind of a compressing effect. So instead of doing that, I'm going to go from 0 to 1070, and that's going to make it so that it looks less compressed. All right, so I'm going to make this bigger so that I can see things. Let's go out of projector mode. So you can see we've got these 2 points here, and then all the other points are right up there. Now, we could try to fit a line using like a ruler, finding 2 points that best define a line, but that's the Algebra 1 way to do it. You guys are in calculus. So instead, we're going to create what's called a regression equation. And that equation is going to look like y equals mx plus b, but it's going to be using the y1 and the x1 from our table. So first I'm going to do y1. And to get that underscore, you have to do the underscore. So shift dash is going to bring it in down below 1. Now you don't want to keep typing in there. So I'm going to arrow over so I'm out of the underscore, and not equals, I'm going to use the tilde, which is next to 1, and you have to hit shift that. And it's called a tilde, it's approximately equal to. And I'm going to use mx underscore 1 plus b. And this will give you its best approximation of what the m and the b are. And we'll also give you some r-squared statistics that we're going to be using pretty soon here, but we're not going to be using them now. So there's our equation. Now we can use that equation to start making some estimations. So let's say we wanted to know what the population was in 1960. So the population is y, so we don't know what that is, but we do know the m, so I'm going to do 6.59287. And if it's 1960, that would be 3 years from 1957. Plus b, which in this case is 638.667. So in 1960, the population of Montana would have been approximately 658,000 people. Now, if I wanted to use this to guess another number, let's say I want to guess what the population is going to be 10 years from now, in 2030. 2030 would be 73 years from 1957. So population in 2030 is going to be approximately 1,119,000. Now this is very useful in the real world because this allows us to do things like plan housing development or what kind of school sizes we're going to be needing, things like that. This is very, very useful in any kind of civil engineering. So there we go. That's regression. Hope you enjoyed. Have a great day.